Okay, so today we're going to talk about the central limit theory. And we're going to do a lot of some word problems that deal with the central limit theorem. Here's a couple of very important things that you need to make sure that you know. You can only use the central limit theorem that these sampling distributions will be approximately normal if the population is normal. So if it's already normal, you're fine. Or you have to have a sample size that's bigger than 30. The other thing that you have to make sure is when you take a sample size, it's not more than 10% of the entire population. Okay, so we're going to actually go through this problem and try to do this problem. You actually, if they ever want the mean or they want the standard deviation, you can find those things even if these things aren't true. But you don't get to know that the population is normal. So this is the big thing that this tells you. The sample distribution is almost normal. It's really, really close. So that's the kind of things that you get to know. We're going to read through this problem and try to figure out what we can do. So it says, more on insurance. An insurance company knows that in an entire population of homeowners, the mean loss will be this. They know the standard deviation for loss will be that. And the reason why the standard deviation is bigger than the mean is because this thing is strongly skewed to the right, just like the population stuff we dealt with yesterday. It says many populations have zero loss and few have great losses. If the company sells 10,000 policies, can it be a safe base that the rate assumption is that we won't have a greater loss than 275? So we need to figure out, can the normal person not lose more than 275? So let's kind of go through and do this. So we need to check a couple things. First thing we need to check is the population normal? And the answer is no, it's not normal. But do we have a sample size that is greater than 30? And the answer is yes. We have a sample size of 10,000. So that checks out. Is it less than 10% of the entire population? Well, I would hope that an insurance company has more than 100,000 clients. That might not be true, but we're going to assume that the insurance company has more than 100,000 clients. So we're going to check that one off so we can use the central limit theory. So then we're going to figure out what the probability that we have greater than this. So we know that with our sampling distribution, we are going to have the mean. Well, I should call this x bar, but it's the same. And the population standard deviation was 300. Now, our standard deviation for our sample will not be 300. It will be 300 divided by the square root of the number of samples that we took, which would be that. Oh, it's probably going to be easier to use my little bit better calculator for this thing. So we'd have 300 divided by the square root of 10,000. So about 3. And we want to know what's the probability that it's greater than, that x is greater than 250. So, not 250, 275. My bad, sorry. And we know it's normal, so it's going to look something like this. This is what we'd like to find. We want to find this space right here. To do that, let's take a z-score. So I'm going to take 275 minus 250 divided by 3. which would give me 25 divided by 3, which gives me 8. So this is about 8 standard deviations away, so I would say we are pretty safe. Because 8 standard deviations away should be 0%. Like this should not even, like this is a 0%. It's probably, it probably has a little bit of a percentage, but so small that you'd never even find it. So we would be safe. So this insurance company could pretty much guarantee that if they charged people $275, that they would always guarantee themselves a profit. And that's kind of how we want to do things today. Really read through and make sure that you can say that the population's either normal or we have a sample size greater than 30. If that's not true, we can't assume the sampling distribution is almost normal. Second thing is you want to make sure that it's not greater than 10% of the population. Like if you take very, very large sample sizes, make sure it's still with like under 10% of the population, or you are going to run into some problems also. The last thing is just make sure that like I don't need the central limit theorem to do this stuff. We can know that the x bars are going to be approximately what the mean is, no matter if we have a big enough sample size or not, and the distributions will always kind of follow this pattern. We just won't be able to do this last part because we won't be able to assume that it's normal. So try the different problems for today.